2, 1, 0. Ignition.
The moon. In your lifetime, it may be the first settlement in space, one that you may even visit someday. For the world is fast entering the most exciting period of exploration since the sea voyages of the great discoverers 5 centuries ago. Tomorrow's explorers will travel on a starry sea of space, perhaps in nuclear-powered ships such as this, which trails its reactor behind. They will go not only to Earth's nearest neighbor, the moon, but also to the nearer planets and perhaps beyond. The decision to send an expedition to the moon was made in May 1961, only a month after Soviet cosmonaut Yuri Gagarin became the first human space traveler. These Soviet stamps commemorated this great event. Aware of the urgency of overtaking Russia's lead in space, President Kennedy told Congress,
"I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth."
Thus, the target date was set at 1970 or earlier. The National Aeronautics and Space Administration, or NASA, moved into high gear to meet it. Early in 1962, John Glenn became the first American in orbit when he circled Earth 3 times in the Mercury capsule shown here. And he was followed by many other successful Project Mercury missions. Nor were the Russians idle either. They lofted into orbit the first spacewoman, Valentina Tereshkova, and the first doctor. They used heavier spacecraft that could carry up to 3 persons. They were able to do this because their rockets had more thrust than America's. And the Russians were first again in another spectacular space feat when Alexei Leonov became the first man to venture outside his spaceship. Leonov drew this picture of himself floating in space. Not until 1965 and 1966 did the United States begin piling up real gains in the race into space. The 2-man teams of Project Gemini performed tasks essential for the perilous 240,000-mile voyage, at the end of which man will set foot on the moon. For instance, astronauts succeeded in maneuvering their ship and changing their course by manual controls, just as they will have to do on the moon voyage. For the first time, they achieved rendezvous with another orbiting vehicle and were able to dock with it, that is, link up with it in space. And in the final Gemini flights, astronauts performed spectacular tasks while working outside their spacecraft. Here, astronaut Dick Gordon straddled the nose of Gemini 11. In the Gemini 12 flight, Buzz Aldrin apparently enjoyed his record-breaking 2.5 hours in space.
Oh, beautiful view. We're completely upside down now.
At one point, he wiped Gemini's windshield in the manner of a filling station attendant. Navy Captain James Lovell, inside at the controls, quipped,
"Okay, would you change the oil too?"
The Gemini missions were so successful that NASA experts thought it possible to advance the schedule and shoot for a Project Apollo manned-to-moon flight earlier than 1970. But suddenly tragedy struck the Kennedy Space Center in Florida. 3 astronauts, Virgil Grissom, Edward White, and Roger Chaffee, were killed in a flash fire as they sat in the Apollo capsule during a rehearsal for takeoff. The Apollo moon program was delayed for investigations and safety modifications on the spacecraft. The tragedy put new emphasis on the whole question of safety in space and the many dangers astronauts must face as they explore the seas of the wild black yonder. For instance, eruptions on the sun shoot out showers of radiation that could be deadly to an unshielded astronaut working in space or on the moon. Also, scientists are not sure how prolonged weightlessness outside of Earth's gravity will affect the human body. 2 Soviet dogs, Blackie and Breezy, who spent 22 days in an orbiting spacecraft, had difficulty walking for more than a week after they returned to Earth. There are other hazards in the vacuum of outer space: meteoroids, extreme heat and cold, X-rays, cosmic rays. Then re-entering Earth's atmosphere after a moon voyage is a tricky business. Too shallow an approach and the Apollo spacecraft might miss Earth altogether. Too steep an approach and the spacecraft might burn up. And the ship might tumble too, preventing its parachutes from working. Apparently, this is what happened when Soviet cosmonaut Vladimir Komarov rode to his death in April 1967. When the three-man Apollo teams go into Earth orbit to practice for the moon trip, they must be ready to face the unexpected both inside and outside their craft. Now, more than ever before, the stress is on safety and less on meeting a set schedule. Though Congress has cut the space budget and more delays are expected in the moon program, NASA officials still have hopes that the Apollo goals will be met. Dr. George Mueller of NASA told Congress,
I believe we will be able to land men on the moon and return them safely to Earth. I believe we still have a reasonable possibility of meeting the goals of the Apollo program.
A roaring 7.5 million pounds of thrust, packed in a 36-story high Saturn V rocket, will lift up the manned Apollo craft when the day for blastoff to the moon comes. By that date, scientists will have selected the position for landing on the moon. Right now, they are mapping the moon's surface, helped by thousands of photos taken by unmanned rangers, lunar orbiters, and surveyors. From orbit around Earth, the three spacemen in the Apollo craft will be given their course to the moon by computers at the Mission Control Center in Houston, Texas, shown here. The computers will calculate the moon craft's trajectory, and at the precise moment when all conditions are go, the craft will set out on its 2.5 day voyage to the moon. Thousands of miles in space, skills learned by the astronauts will be put to a hard test, and Apollo will be rearranged to become the craft that will make the rest of the journey to the moon. The spent third stage of the once huge Saturn rocket at left will be jettisoned, and the command and service module at left will turn around and dock with the spidery lunar landing craft on the right, nose to nose. It is this lunar module that will actually land on the moon's surface. The astronauts will correct Apollo's flight to assure entry into moon orbit about 80 miles above the surface. Then 2 of the 3 astronauts will descend to the moon in the landing bug. What will they find, these modern Magellans, on the lunar New World that for centuries has inspired poets and lovers and fascinated astronomers with its mysteries? The moon's air is a vacuum, for there is no atmosphere. In the shade of craters and in the lunar night, which lasts 350 hours, it is colder than Antarctica. But on the moon's sunlit surface, temperatures are well over 200 degrees, hot enough to boil water. The moon has very low gravity, and heavy objects will be easy to carry, so the astronauts should have little trouble handling 80 pounds of its gritty soil and rocks to take home as a specimen. The moon's low gravity and lack of atmosphere will also make it easy for the astronauts to take off from the surface, leaving behind the 4-legged base of the landing craft. But linking up with the orbiting command vehicle at right is once again a tricky problem of rendezvous and docking. Once hitched up, the team will set course for Earth. But will the modern explorers make it to the moon and back safely? Professor Isaac Asimov, biochemist, mathematician, science fiction writer, speaks optimistically.
The wooden hulls that pushed off from Spain faced a voyage much longer in time than the one that separates us from the moon. The ocean voyagers were frightened men, not knowing where they were going, ill-fed, poorly cared for, completely isolated from home. Our astronauts are superbly trained and cared for, highly motivated, and at all times in contact with home. The advantage is all with the first men to the moon over the first men to America.
Man will go to the moon. But why? Some ask, wouldn't the huge sums we are spending, about $23 billion for the moon program, be better spent on improving life on Earth? President Kennedy provided one answer.
We go into space because whatever mankind must undertake, free men must fully share.
And man has dreamed of space travel and lunar voyages since the earliest times. For example, it is said that the Chinese Emperor Wan Hu set out for a space voyage in 1500. His spacecraft consisted of a chair propelled by 47 rockets and steered by kite-like fans. But Wan Hu exploded on takeoff. Today, for better or worse, space accomplishments have become a source of national prestige. For this reason, the United States is trying to be first on the moon. Russia is believed to have plans for a moon voyage too, as well as plans for a permanent satellite above Earth to serve as an observation post and fueling station. There may be resources on the moon that will be valuable to man when he first attempts to build a base there. Man needs to investigate the geology of the moon at first hand. In the words of Eugene M. Shoemaker of the United States Geological Survey,
what we really want to do is put a man down there. Geological exploration by instruments landed remotely on the moon is inefficient and incomplete. A man walking over the lunar surface is more effective in examining and sampling it.
also, we are gaining important products and byproducts of the race to the moon. Fuel cells, such as these, and new alloys, pyroceram dishes, new paints, and plastics. Biosensors such as this that listen to the functions of the human body, and hearing aids improved through miniaturized electronics. By using biosensors, hospitals can monitor through a central control board the condition of many heart patients or other ill persons. Other dividends, or as the scientists say, spin-off of space exploration, are weather prediction, land surveying, and aids to navigation by means of satellites, and television and telephone communications over oceans and continents via such satellites as Early Bird and Russia's Molniya. Perhaps most important, scientists expect that the exploration of the moon will yield abundant information about our solar system and even the origin of the universe. And there will be answers to questions that have been dogging scientists for years, such as, does the moon have minerals unknown on Earth? Is there water under its surface? Are there volcanoes on the moon? Preliminary tests made by Surveyor 5 indicate that the moon is made of soil and rocks like the Earth's. The moon is a head start toward other goals in space, such as long-range programs for a manned laboratory in orbit around Earth. Even now, NASA plans, if funds are made available, to venture further out into the solar system. Space agency plans include a rocket flight that will carry instruments to Venus in an attempt to penetrate the planet's thick atmosphere. Already, Russia has landed an instrumented capsule on Venus. Another unmanned mission will carry an instrumented craft on an adventurous ride to the outer planets, Jupiter, Saturn, Uranus, and Neptune. And NASA has long-range plans to send instruments to Mars as a prelude to a manned voyage someday. According to some scientists, life, in a very simple form, may already exist on Mars. But the moon voyage we are preparing for is not just a warming-up exercise for trips to somewhere else. The moon is important in its own right. Its greatest export will be knowledge. Early settlers in a scientific moon colony may have to live under moon's surface, protected from the ceaseless rain of tiny meteorites, ultraviolet rays from the sun, and X-rays and cosmic rays from space. Only much later, perhaps after the year 2000, will moon folk enjoy surface living. The buildings will probably be bright and airy, employing new structural forms made possible by the moon's low gravity. Crops and vegetables will be grown on hydroponic farms, using chemicals instead of earth. And there will be factories, too. In the vacuum on moon's surface, some things could be manufactured more efficiently than on Earth. Microcircuits, optical instruments, pharmaceuticals, light products that could easily be rocket shipped to markets on Earth. In the deep cold of moon's nighttime, techniques for freezing living tissue could be developed, and low-temperature surgery might open new fields of medicine. By day, batteries that store the intense energy of the sun will recharge. Either batteries or nuclear power plants such as this will supply the moon colony with power. And some scientists have speculated that perhaps someday power sent from the moon by radio waves or light rays, called laser beams, could supply part of Earth's power needs. In the moon's low gravity, where movement is easy, exercise will not only be necessary for health, but fun. Jump, flap your plastic wings, and soar like a bird. But the moon colony's prime function is work, hard scientific observation. Telescopes will see far out, and much more clearly than our earthbound ones, that can penetrate only dimly the obscuring effects of the atmosphere. Observations will be made not only of the stars, but also of Earth's weather, tides, and land formations. Scientists plan to position a radio telescope on the side of the moon that never faces Earth, and is therefore shielded from Earth's constant babble of radio noises. By analyzing radio emissions in space, we may unlock new knowledge about celestial bodies in the distant realms of the universe. Will we also get coded radio beacons from living creatures on other worlds? Just what are the chances, anyway, that intelligent life exists on some faraway island in space? We posed this question to Walter Sullivan, science editor of the New York Times.
It seems to me almost impossible to believe that there is not life scattered all through the universe, including intelligent life. Now we know that while there are billions of stars in our own system, the Milky Way galaxy, that for each of these stars you can look beyond and see another galaxy with its billions of stars. And many of these stars have planets, and certainly a certain percentage of these planets will be like the Earth in all essential respects, with life very likely to arise, and hence ultimately intelligent life. I believe that we are not alone in the universe.
But life on other planets or not, Earthman, now gone into space, will have to make many new adjustments on how to live with his fellow men in the hostile, difficult environment above Earth. President Johnson has hailed a treaty between the United States and Soviet Union for the peaceful use of space. Calling for more cooperation between the big powers, he said,
"Let us determine that the great space armadas of the future will go forth on voyages of peace, and will go forth in a spirit not of national rivalry, but of peaceful cooperation and understanding."
How will man's bold adventure into space change his spiritual and political beliefs, his concepts of living, his values of beauty? The answers will begin to unfold in your generation as man sets course for his first celestial target, the moon.